this lesson is to solve. Some quadratic equations cannot be easily solved by factoring. Square roots can be used to solve some of these quadratic equations. Recall from lesson 1-5 that every positive real number has two square roots, one positive and when you take the square root of a positive number and the sign of the square root is not indicated, you must find both the positive and negative square root. This is indicated by plus or minus the square root. So 3 times 3 is 3 squared, or 9. The square root of 9 is 3. That's the positive square root. But negative 3 times negative 3 is negative 3 squared, which is also 9. So the square root of 9 could be negative 3. Plus or minus the square root of 9 equals plus or minus 3. To solve a quadratic equation in the form x squared equals a, you take the square root of both sides. The square root cancels out with the square, and then you write plus or minus the square root of the number on the other side. So if we had x squared equals 15, we would take the square root of x squared, the square and the square root cancel each other, equals plus or minus the square root of 15. So we would get x equals plus or minus square root 15. If x squared equals a, and a is a positive real number, then x equals plus or minus the square root of a. Solve using square roots, check your answer. X squared equals 169. We're going to solve for x by taking the square root of both sides using plus or minus to show the square roots. So we get x equals plus or minus square root 169. The square root of 169 is 13, so we get x equals plus or minus 13. So the solutions are 13 and negative 13. If we wanted to check our answer, we could substitute 13 and negative 13 back into the original equation to see that it works. So we would get 13 squared equals 169, and 169 does equal 169. And then we would get negative 13 squared equals 169, and 169 does equal 169. So we know our answers are correct. Solve using square roots. X squared equals negative 49. So we would take the square root of both sides and we get x equals plus or minus the square root of negative 49, but there's no real number whose square root is negative. So there's no real solution. Solve using square roots, check your answer. X squared equals 121. This one's for you to try and then you can check back for your answer. So we're going to solve for x by taking the square root of both sides using plus or minus to show both square roots. And we get x equals plus or minus the square root of 121. The square root of 121 is 11, so we get x equals plus or minus 11. So the solutions are 11 and negative 11. We're going to substitute 11 and negative 11 to the original equation to check our answers. So we get 11 squared equals 121, so 121 does equal 121. And then negative 11 squared equals 121, and 121 equals 121. So we know our answers are correct. Solve using square roots, check your answer. X squared equals 0. This one's for you to try and then you can check back for your answer. We're going to solve for x by taking the square root of both sides, showing plus or minus to show both square roots. So we get x equals plus or minus the square root of 0. And since obviously there's not positive negative 0, we just get x equals 0. So the solution is 0. We're going to check by putting it back into the original equation, and 0 squared does equal 0, so we know our answer is correct. Solve using square roots, check your answer. X squared equals negative 16. This one's for you to try, and then you can check back for your answer. So when we take the square root of both sides, we get plus or minus the square root of negative 16, and there are no real numbers whose square is negative, so there is no real solution. If necessary, use inverse operations to isolate the squared part of the quadratic equation before taking the square root of both sides. So solve using square roots. X squared plus 7 equals 7. So we're going to subtract 7 from both sides, leaving us with x squared equals 0. Now we can take the square root of both sides, and we get x equals plus or minus the square root of 0, which is just 0. So the solution is 0. Solve using square roots. 16x squared minus 49 equals 0. We're going to add 49 to both sides to isolate the x squared term, and we get 16x squared equals 49. Then we're going to divide both sides by 16, and we get x squared equals 49/16. Now when we take the square root of both sides, we're still going to use plus or minus to show both square roots. Remember, when it's a fraction, you take the square root of the top and of the bottom. So we get x equals plus or minus the square root of 49/16, which would be plus or minus 7, that's the square root of 49, fourths, that's the square root of 16. The solutions are positive 7/4 and negative 7/4. If we were going to check our answer, we could plug 7/4 back into the original equation and solve. Squaring it, we would get 49/16, multiply by 16, and we'd get 49 minus 49, which is 0. If we tried -7/4 and squared it, we'd get 49/16, and multiply that by 16. Those cancel, and we get 49 minus 49, which is 0. So we know we've got our answers correct. Solve by using square roots. Check your answer. 100x squared plus 49 equals 0. This one's for you to try, and then you can check back for your answer. So we're going to subtract 49 from both sides, and we get 100x squared equals -49. And then we're going to divide both sides by 100. Remember, we're trying to isolate the x squared. And we get x squared equals -49 100ths. But when we take the square root of both sides, that means that it's plus or minus the square root of -49 100ths. And there's no real number whose square is negative, so there's no real solution. Solve by using square roots. Check your answer. In parentheses, x minus 5 squared equals 16. This one's for you to try, and you can check back for your answer. So you're going to take the square root of both sides using plus or minus to show both square roots. And when you square root the x minus 5 squared, the square and the square root cancel, and you're just left with the x minus 5. And then when you square root 16, you get plus or minus the square root of 16, which is 4. So x minus 5 equals plus or minus 4. Then we're going to write two equations using both of the positive and negative square roots, and then we're going to solve them. So we'd have x minus 5 equals positive 4, or x minus 5 equals negative 4. And we add 5 to both sides to solve, and we're going to get x equals 9 or x equals 1. So the solutions are 9 and 1. If we were to check, we could plug 9 back into the original equation to see if it equals, and we get 9 minus 5, which is 4, squared is 16, so 16 equals 16. And we get 1 minus 5, which is -4, squared, and then we get 16 equals 16. So we know our answers are correct. When solving quadratic equations by using square roots, you may need to find the square root of a number that's not a perfect square. In this case, the answer is an irrational number. You can approximate the solutions using a calculator. Solve round to the nearest hundredth. X squared equals 15. So we're going to take the square root of both sides. That gives us x equals plus or minus the square root of 15. 15 is not a perfect square, so you're going to type it into the calculator and hit the square root button. And we get x is approximately, that's the squiggly equals, plus or minus 3.87, round to the nearest hundredth. So the approximate solutions are 3.87 and -3.87. Solve round to the nearest hundredth. -3x squared plus 90 equals 0. We're going to subtract 90 from both sides and divide by -3 on both sides. And so we get x squared equals 30. Take the square root of both sides, and we get x equals plus or minus the square root of 30. 30 is not an even square root, so we're going to a perfect square. So we're going to take a calculator and type it in, hit the square root button. And we get x is approximately, that's the squiggly, equals plus or minus 5.48, rounding to the nearest hundredth. So the approximate solutions are 5.48 and -5.48. Solve round to the nearest hundredth. 0 equals 90 minus x squared. This one's for you to try, and then you can check back for your answer. So we're going to add x squared to both sides, and that gives us x squared equals 90, and then we're going to take the square root of both sides, and we get x equals plus or minus the square root of 90. 90 does not have a perfect square root, so we're going to use a calculator, and we get x is approximately plus or minus 9.49. So the approximate solutions are 9.49 and -9.49. Solve round to the nearest hundredth. 2x squared minus 64 equals 0. This one's for you to try, and then you can check back for your answer. So we're going to add 64 to both sides. We're isolating the x squared term, and then we're going to divide 2, and we get x squared equals 32. Take the square root of both sides, and we get x equals plus or minus the square root of 32. 32 does not have a perfect square, so we use a calculator to find the approximation rounding to the nearest hundredth, and we get x is approximately plus or minus 5.66. So the approximate solutions are 5.66 and -5.66. Solve round to the nearest hundredth. X squared plus 45 equals 0. This one's for you to try, and then you can check back for your answer. So you're going to subtract 45 from both sides, and you get x squared equals -45. So we take the square root of both sides and we get x equals plus or minus the square root of negative 45, and there are no real numbers whose square is negative, so there is no real solution. Miss Pirzada is building a retaining wall along one of the long sides of her rectangular garden. The garden is twice as long as it is wide. It also has an area of 578 square feet. What will be the length of the retaining wall? So we're going to let x represent the width of the garden. Area is length times width, and length is twice the width. So we're going to substitute x for w, and 2x for the length, and 578 for the area. So we get 2x times x equals 578. So 2x times x is 2x squared equals 578. We divide both sides by 2, and we get x squared equals 289. And then we're going to take the square root of both sides, and we get x equals plus or minus the square root of 289. We type in square root 289 on a calculator, and it does come out to be a perfect square at 17. So we get x equals plus or minus 17. Negative numbers are not reasonable for width. Obviously, she's not going to make a wall that's negative feet. So x equals 17 is the only solution that makes sense. So the length is 2 times the width. So that would be 34 feet for the retaining wall.